Okay, so we're going to integrate this trig function that you see here, sine x cos x, and so we want to integrate this expression here. We're going to use substitution to do this question, and we actually have two ways of approaching this question. It all depends on your first step. So I'm going to let u be equal to sine x for this first step that I'm going to make here. Now, if I look ahead here, because if you haven't noticed yet, for integration using substitution, you do have to look ahead. When I take the derivative of sine x, I'm going to get a cos x, which will then help me eliminate the cos x in the integral. So, first of all, that's my first thing I'm going to do. Is going to let u be equal to sine x. So I get u times cos x dx. So I somehow need to eliminate the cos x dx and rewrite it in terms of u instead. So from u is equal to sine x, I'm going to integrate both sides with respect to x. That was my first thing I do. So then I get du dx is equal to the derivative of sine x gives you cos x, and so that's pretty much all I do there. Now to get cos x dx, I can do that by taking the dx and bringing it to the other side, and I get cos x dx. Okay, so I'm going to make that substitution now. So u cos x dx is really du. So this is actually pretty easy to integrate, because all we're going to get here is u to the power of 2 over 2 plus c, where u was originally sine x. So pretty much that's my integral right there. I mean, there's my answer. So it really didn't require a lot of steps there. But I want you to notice one thing here. We actually could have done the same thing, but instead of letting u be equal to sine x, I could have done it by letting u be equal to cos x. So if I look ahead, if I take the derivative of cos x, I actually get sine x, or negative sine x. So what that allows me to do, I'm actually going to go back to the original question, sine x cos x dx, that allows me to actually get rid of the sine x in front. So this is what this solution may look like. So I'm going to rewrite it as the integral of sine x, cos x is really u, dx. So I somehow need to rewrite sine x dx in terms of u instead. So taking the derivative here, I'm going to get du dx on this side, and then derivative of cos x is just negative sine x. So I can actually see it here. I can get dx times sine x by taking dx and bring it to the other side, and I get du is equal to negative sine x dx, but my problem is negative. So I'm going to bring the negative over to the other side, so I get negative du is equal to sine x dx. So I can make that substitution in here. I'm going to get the integral of sine x times dx, which is really negative du. So I'm going to get a negative u times sine x dx, which is just du. So from this stage, I can actually integrate. You could just ignore the negative here. I'm going to get negative u to the power of 2 divided by 2 plus c. And what I end up getting here, once again, u was originally cos x. So cos x, I'm going to put that in here, so I get cos squared x divided by 2 plus c. So you may be wondering, how are these two expressions, sine squared x over 2 plus c, and negative cos squared x over 2 plus c, how are these the same? Because they don't look the same. But in fact, they are. And one thing we can do to make them the same, to prove they are the same, is use identities, which is everybody's favorite thing to do, is using trig identities. So let's go ahead and do that. Negative cos squared x. There is actually identity that relates it to sine squared x, and it's this identity right here. So just on the side here, I know that sine squared x plus cos squared x is equal to 1. So therefore, if I was to make this a negative cos squared x from here, what I'll get is negative cos squared x on this side, and this is sine squared x minus 1. So I'm going to use the identity here. I'm going to replace negative cos squared x with sine squared x minus 1 over 2 plus c. Okay, so are they the same? They're almost looking the same. But the one thing I have to do here is deal with this minus 1 over 2. So actually, we can rewrite it like this. Okay? I can rewrite it like this. Sine squared x over 2 minus 1/2 plus c, right? So I just split up this quotient into two different fractions, okay? Now, c is just a constant. Negative 1/2 is just a constant. When you take two constants and put them together, you get a constant. So therefore, I get sine squared x over 2. Negative 1/2 plus c is generally just c. So now they're the same expression as what I got up here. So it all depended on your first step. You actually could have integrated this in 4 steps, or if you let u be equal to cos-x, it's a few more steps involved. So that's pretty much how you do that question.